The next and final lesson in our reaction and stoichiometry unit is on theoretical and percent yields. One learning target for this lesson, we want to be able to calculate theoretical and percent yields. Before we get into the calculations, let's take a look at some basic definitions. A theoretical yield, it is the maximum amount of product that can be produced by a given amount of reactants. All the calculations that we do in stoichiometry, they are all theoretical calculations. So all the calculations that we've worked on, the examples, all the problems that we have done, that we've seen, even though the terminology was not used, those were all theoretical calculations. So for example, if the question asks you to calculate how much of a certain product would be produced in a reaction, that is a theoretical calculation. It is actually the maximum amount that we could get. Doesn't mean it's actually what we're going to be able to collect, but it is the maximum amount. The actual yield is what it sounds like. It is the amount of product that's actually produced or obtained in a chemical reaction. You cannot calculate this. This is something that simply comes from your experimental data, from your measurement. There's no way that you can do a calculation to determine how much you will collect. You just have to measure it. Finally, a percent yield. A percent yield is a way to measure experimental or reaction efficiency. It is calculated as follows. The percent yield is calculated by taking the actual yield. Remember, that's what you collect in the experiment, and you divide by the theoretical yield, which is calculated, and then you multiply by 100 to turn that into a percentage. Now, I want you to consider what this percent yield tells us and ask yourself, is there any way that this percent yield could ever be more than 100%? The answer to that question would be no. There's no way that a percent yield should ever be more than 100%, because the theoretical yield is the maximum amount that we can collect. So the theoretical yield, that's the most you can get. There's no way that you can get a yield, an actual yield of more than that, if the theoretical is in fact the maximum. So 100% is the maximum is the maximum percent yield that you can get. However, due to experimental errors and other various situations, you might have data that gives you more than 100%, but it cannot possibly be correct. Let's take a look at how we actually do these calculations to find theoretical and percent yields. Let's just consider this reaction between potassium chromate and silver nitrate. You're given the equation for the reaction here. And we're asked, what is the theoretical yield of silver chromate if 0.500 grams of silver nitrate reacts with excess potassium chromate? In this problem, we know that the silver nitrate is limiting because we're told that the potassium chromate is in excess. So what that tells us then is the yield, in other words, how much we can get, will be based on the silver nitrate amount. So we're told we have 0.5 grams of silver nitrate. We want to know what the theoretical yield of silver is. So this is just a gram mole mole gram problem because we already know what the limiting reactant is. We know that that limiting reactant determines the amount of product that can form. So we're just doing a gram mole mole gram problem, starting with our mass of silver nitrate, converting that into a mass of silver chromate using the molar mass of silver nitrate as we know how, and then the balanced mole to mole ratio from the equation. We can see it's 2 moles of silver nitrate to 1 mole of silver chromate, and then the molar mass of silver chromate. This gives us a value of 0.488 grams of silver chromate. Okay, so what this tells us then, if all the 0.5 grams of silver nitrate reacts, we'll get 0.488 grams of silver chromate, meaning that that is the theoretical yield in this reaction of 0.488 grams of silver chromate. Now note, this question could have also asked us to find the theoretical yield of the potassium nitrate, and we would do the problem the same way, with the exception of we would find the mass of potassium nitrate instead of the mass of silver chromate that we did here. Alright, so we've answered question A. We've determined that the theoretical yield is 0.488 grams of silver chromate. Now let's say we actually do this reaction and we collect our silver chromate product and it yields 0.455 grams of silver chromate. We want to know what our percent yield is. So recall that is simply the actual yield divided by the theoretical yield times 100. We're told that we collect the 0.455 grams of silver chromate, so that's my actual yield, divided by the 0.488 gram theoretical yield that we already found, and then we turn that into a percentage. That will give you 93.2% yield. Let's look at a different example. Here we're considering the reaction between zinc and hydrochloric acid. And we're told if 25 grams of zinc are reacted with 23.2 grams of hydrochloric acid, what is the theoretical yield of zinc chloride? In this problem, we have to determine our limiting reactant. Even though the question does not ask us to do that, we are asked for the theoretical yield of the zinc chloride. Now we are given a mass of both the reactants. We're told we have 25 grams of zinc, 23.2 grams of hydrochloric acid. Based on that alone, we do not know which of these, the zinc or the hydrochloric acid, will determine the amount of product. In other words, we don't know which one is limiting. So that's why we have to determine the limiting reactant. So we will find the mass of zinc chloride that both of these could produce if they all reacted. We'll just do the zinc first because it's listed first. So this is a gram mole mole gram problem like we have seen. So use the molar mass of zinc. Your mole to mole ratio, notice it is 1 to 1 here in the balanced equation. And then the molar mass of zinc chloride. This gives us 52.1 grams of zinc chloride. Recall what that tells us is if all 25 grams of zinc react, this is the mass, the 52.1 grams of zinc chloride that could be produced. We'll do the same thing with the hydrochloric acid using a gram mole mole gram problem. Molar mass of hydrochloric acid. Your balanced equation shows a 2 to 1 mole ratio. And then again the molar mass of zinc chloride. This will give you 43.4 grams of zinc chloride. So we've determined the limiting reactant. We know that HCl is limiting because it will give us less product, and thus our theoretical yield of the zinc chloride is that 43.4 grams, because that's the maximum amount that we could produce from that limiting reactant. So we've answered question A. Question B. Calculate the percent yield if you collect 31.7 grams of zinc chloride from the reaction. So just like in the previous problem, here we're given the amount that we collect. We're told that we get 31.7 grams. We already calculated our theoretical yield, so we can use our equation for percent yield. We'll take the actual of 31.7 grams divided by the theoretical of 43.4 grams, turn it into a percentage by multiplying it by 100, and that gives you 73.0% yield. Alright, here's a practice problem. Once the problem's up, pause the video, try it yourself, and see how you do. Here's our question. To perform the following reaction, you drop a copper wire weighing 1.62 grams in a solution containing 0.850 grams of silver nitrate. You collect 0.262 grams of silver as a product. What is your percent yield? So notice you're given the balanced equation here. We're asked to find our percent yield, and we are given the actual yield. We're told that we collect 0.262 grams of the silver as a product. Now if you consider what we're asked to do here, asked to find the percent yield, that means we have to find the theoretical yield. In order to find a percent yield, we have to know what that theoretical yield is. Even though the question doesn't ask us to give the theoretical yield, we have to calculate it in order to find the percent yield. Likewise, if we're going to find the theoretical yield, we have to know what the limiting reactant is. We're given a mass of copper and a mass of silver nitrate, and we need to find our percent yield of silver. I need to know which of these two reactants is going to determine the amount of product that can form. So we need to find our limiting reactant, even though we're not asked to do that. So again, this is just a couple of gram mole mole gram problems. We'll start with the copper. We have 1.62 grams of copper, using the molar mass of copper to convert that to moles. And then we'll use our mole to mole ratio. Notice we get 2 moles of silver for every 1 mole of copper. Then our molar mass of silver gives us 5.50 grams of silver if all of the copper reacts. Now we need to do the same calculation for the silver nitrate. We have 0.85 grams of silver nitrate, using the molar mass of silver nitrate to convert that to moles. Our balanced equation shows us a 2:2 mole ratio for the silver to silver nitrate. And then again, the molar mass of silver. This gives you 0.540 grams of silver. From this, we know that the silver nitrate is the limiting reactant. I can tell because it will give us the least amount of product. And because of that, I know that this 0.540 grams of silver is our theoretical yield. Now to actually answer the question, we're asked to find the percent yield. Now that we know the theoretical yield is 0.54 grams, we can make this determination. We'll take our actual yield of 0.262 grams of silver divided by the theoretical yield that we just calculated of 0.54 grams of silver. This gives you 48.5%. Alright, this concludes the final lesson in the reaction stoichiometry unit. In this lesson, we were able to calculate theoretical and percent yields. Remember that all the calculations that you do with stoichiometry, those are the theoretical calculations. The percent yield we get from the actual yield once we've calculated the theoretical as well. And remember that actual yield is only determined by experimentation. We cannot calculate it.